Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, how are you today? My name is Salma Zofia Habibah. My name is 22/11/7/2023. Now I can tell you about capacitor. So what is a capacitor? Capacitor is a device that can store energy or electric charge in an electric field by collecting an internal imbalance of electric charge or an electrical component that is capable of storing electric charge formed by collected surface, disks or plates that are separated by a partition. Function or use capacitor. 1. To store electric current and voltage temporarily. 2. As a filter in an electronic circuit such as a power supply or adapter. 3. To eliminate reflections part when installed on a switch. Number 4. As a link between one electronic circuit and another electronic circuit. Number 5. To save electrical power when installed on neon light. Number 6. As an insulator or electric current barrier for DC or direct current. Number 7. As a conductor or conducts electric current for AC or alternating current. Number 8. To flatten then DC voltage wave in the circuit convert AC voltage to DC. Number 9, as an oscillator or AC wave generator, back and forth, and so on. Type of capacitor. Number 1, tantalum capacitor. This is a type of electrolytic capacitor whose electrode is made of tantalum material. This component has polarity. How to differentiate it is by looking for the plus sign on the capacitor body. This sign indicates that the pin underneath has positive polarity. Please be careful when installing component counts. They must not be reversed. The temperature and frequency characteristics are better than electrolytic capacitor made from aluminum. Next, ceramic capacitor. Capacitor use titanium acid, barium as their electric because it is not constructed like a coil. This component can be used in high-frequency circuit. Frequency response characteristics will need to be taken into account, especially if the capacitor works at high frequencies. For frequency response calculation, the quality unit key quality factor is also known, which is known other than 1 or dV. Usually used to pass high-frequency signal to ground, this capacitor is not good for analog circuit because it can change the shape of the signal. This type has no polarity and is only available with very small capacitor values. And then electrolytic capacitor. The electrolytic capacitor group consists of capacitor whose dielectric material is a metal oxide layer. This capacitor electrode is made of aluminum, which uses the oxidation membranes. Generally, capacitor included in this group are polar capacitor with plus or minus sign of their bodies. Due to this characteristic, user must be careful when installing it in the circuit, so as not to reseparate. If the polarity is resevered, it will be damaged and even explode. Usually, this type of capacitor is used in power supply circuits, low pass filter, and time circuit. This capacitor cannot be used in high frequency circuit. Next, multi-layer ceramic capacitor. The material for this capacitor are the same as ceramic capacitor. The difference is in the number of layers that make up the dielectric. In this type, the dielectric is arranged in many layers or usually called layer with a thickness of 10 to 20 microamp, and the electrode plate is made of pure metal. Apart from that, they are small in size and have better temperature characteristics than ceramic capacitor. Usually, this type is good for application or passing high frequencies to group. Next, polyester film capacitor. Capacitor B side have a high test tolerance value than polyester film capacitor. In general, the capacitance value of this component will not change if it's designed in a system if the frequency passing through it is less than or equal to 100 kilohertz. In the future above, a polypropylene capacitor with a tolerance of plus minus 1% is shown. This type of capacitor is also still being developed to being large but small and light capacitor, for example, for electric car application. Next, mica capacitor. These types use mica as the dielectric material. Mica capacitors have a high level of stability because their temperature coefficient is low. Because the frequency characteristics are very good. These capacitors are usually used for resonance circuit, filters for high frequencies, and circuit that use high voltage. For example, radio transmitter that use transistor tube. Mica capacitors do not have a high capacitance value, and the price is also relatively high. Next, polystyrene film capacitor. The dielectric of this capacitor is polystyrene film. This type cannot be used for application that use high frequencies because its constriction is the same as electrolytic capacitor, namely like a coil. These capacitors are good for time and filter application that use frequency of several hundred kilohertz. This cabinet has two colors for its electrodes, namely red and gray. For the red one, the electrode is not of copper, while the gray or is made of aluminum foil. And then electric double capacitor or supercapacitor. This type of capacitor has the same dielectric material as electrolytic capacitor. However, the difference is the size of the capacitor is larger than the electrolytic capacitor described above. Usually, it has units of B. This capacitor have a large voltage limit because it has a voltage limit and a shape that is larger than other capacitor. This capacitor is also called a supercapacitor. An image of its physical form can be seen above. In figure 2, 2.13, the capacitor has a size of 0.47 T. This capacitor is usually used for power supply circuit. And then trimer capacitor. Other types of capacitor use ceramic and plastic as the dielectrical material. The value of the capacitor can be charged by turning the screw above it. When tying, you are expected to use a special screw drive so as not to cause a capacitance error between the screwdriver and your hand. Next, tuning capacitor. In Japan, these capacitors are called counts, usually used as wave selector or on radios. This type of dielectric uses air. The capacitance value can be changed by turning the handle on the capacitor body to the right or left. Um, and then how capacitor work? In the operation of a capacitor, there are only two cycles, namely the charge and discharging cycle. In theory, when two metal conductors passing through the electron are electrified by an electric current, one of the capacitor ledge attached to the negative current will have many electrons, whereas the capacitor ledge attached to the positive pole will lose many electrons. This is caused by the electric between the two legs of the capacitor so that current for the positive charge to the negative charge will not flow. This charge will be retained stored at both end of the capacitor's dielectric. At times like this, the capacitor is in a charging cycle. This process can be likened to the phenomenon of the accumulation of positive and negative electrical charge that occurs in clouds before lightning occurs. A capacitor can pass AC current depending on its capacitive value. The smaller the capacitance value of the capacitor through which AC current passes, the smaller the current that flows through it. In capacitor through which DC current passes, the current will remain at the edge of the electric. In other words, the DC current will be restrained because of the electric throw which it space. The smaller the capacitance value of the capacitor throw which this current passes, the smaller the current is passes. A capacitor that has been given an electric charge at a certain time is then less gain than in the capacitor, and electric change is stored according to the capacitor value of the capacitor. The greater the capacitance value, the greater than amount of charge that can be stored. And usually this will be directly proportional to the exchange time. So that's all I can say about capacitor. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.